In a world where we live, genetic drift, a force that has a bad effect on small populations. Let's talk about how genetic drift can be random and really affect a small population. Okay, so let's say you're on a soccer team for a small school. Okay, you only have about 300 people in your school, you have 15 people on your soccer team, and you guys are really good. You're going to states. All right, and unfortunately, on that Thursday night before you leave for states that weekend, 5 people just randomly come down with the flu. Well, you're moving on to states with 10 people, and those 5 aren't going, so you don't have their abilities anymore to help you on your team. And it wasn't on purpose, it was just a random flu bug. And so now you 10 are rolling to states, and you're going to do the best you can with your abilities. Now let's juxtapose that to a huge school of, let's say, 3,000, okay? And they have 50 people on their soccer team. And again, a random flu bug hits them too, and they lose 5 people. Well, okay, now they have 45 people going to states, putting all of their skills into that state championship game. Which team do you think is going to be more affected by just this random flu bug? Yeah, the small team, because small populations are more affected by these random events than large populations, right? That is why genetic drift affects small populations way more than it affects big populations. Because when you're talking about a small set of alleles, or in our soccer example, a smaller set of skills, if you remove some of those skills or alleles, then it's going to have a much larger effect on that small population. Okay? Does that make sense? Okay, fantastic.